Hi, here's yet another math lesson from us, and for today we will be exploring the topic trigonometry. To start with, we will learn about the trig ratios of obtuse angles. From there, we will move on to the sine and cosine rules for triangles. We will then take a look at a new and unconventional way of finding the area of a triangle. We will study bearing and lastly look at angles of elevation and depression. To the next section, the cosine rule. Here's our cosine rule. There are so many formats in which it can be written because we can play around with the values and rearrange them. But before we get there, we need to understand where the cosine rule comes from and how it is useful. Just like we did in an attempt to find how the sine rule comes to being, we have a non-right angled triangle made up of two right angled triangles. For triangle ABC, we first deal with each triangle separately. We use the Pythagoras theorem for triangle BDC. From it, we know that hypotenuse squared is equal to opposite squared plus adjacent squared. Our hypotenuse is A, our opposite is H, and our adjacent is found by subtracting x from C. This leads us to A squared is equal to H squared plus C minus x squared. In triangle ACP, when we apply the Pythagoras theorem, B is our hypotenuse, H is our opposite, and x is our adjacent, such that B squared is equal to x squared plus H squared. From our trig ratios, we know that the cos of an angle is found by dividing the opposite by the hypotenuse. This means that in triangle ACP, cos A is equal to x over B, and in turn, x becomes equal to B cos A. Now we have our three equations, and this is the main one, and we'll call it equation 1. This will be our equation 2, and this will be our equation 3. We'll be substituting equation 2 and 3 into equation 1. I'll rewrite our main equation. A squared is equal to H squared plus x squared plus c squared minus 2cx. Now, when we rearrange our second equation, we find that h squared becomes equal to b squared minus x squared. This means that for our h, we can substitute it with b squared minus x squared plus x squared plus c squared minus 2cx. When we do this, the 2x squared values cancel each other because there's a negative and a positive. And this brings us to a squared is equal to b squared plus c squared minus 2cx. Now we're left with our third equation. For us to use it, we first have to make x the subject of the formula, and we do that by multiplying cos A and B, such that it becomes x is equal to b cos A. This means that where we have x in this equation, that is right here, we are going to substitute it with b cos A, and that becomes b squared plus c squared is equal to 2bc cos A. And this is our cos formula. Using a formula with a different arrangement can give us the same results. We can do this by changing the subject of the formula, such that it comes out in different ways, like the following. The cosine rule is used when we're given two sides and an angle, or when we're given three sides. For example, in triangle LMN, L is 130 degrees, M is 6 centimeters, and N is 5 centimeters. Now we are required to find MN. Our general cosine formula is a squared is equal to b squared plus c squared minus 2bc cos A. We now have to customize it for this particular question, and that way it becomes L squared is equal to m squared plus n squared minus 2mn cos L. Next, we plug in the values provided in the diagram, and that leads us to 6 squared plus 5 squared minus 2 multiplied by 5 and by 6 cos 130. We further simplify this and we get 36 plus 25 minus 60 cos 130. When we enter this in our calculators, the value we get is 99.56, and the number goes on and on. When you find the square of this number so that we get the value of L, it becomes 9.978, and the number goes on and on. What we do next is round off this number, and what the answer we get is 10 centimeters. We have been calculating the areas of triangles using the popular formula half base times height. However, it is not always the case that we are given the height. When that happens, we multiply two given sides by half, and then the sine of an angle whose opposite side we do not include. This means that the formula can be half AB sine C, or half BC sine A, or half AC sine B. Let us use this method to find the area of a given triangle. The appropriate formula to use is half AC sine B. This is because B is the only angle whose size we know. We punch this in our calculator and substitute A and C with actual values from the diagram given. And we would have half multiplied by 8 multiplied by 11, and then we have our sine B, that's sine 40. We can start by first simplifying this part, and that would give us 44 sine 40. And when we simplify this using our calculators, we find that the area of this triangle is 28.282, and the number goes on and on. When we round it off to one decimal place, we get 28.3 square centimeters.